Hello everyone. I guess we can start, right? So hello again. So it's Raja from Singapore. Fine morning here. Okay. So yeah. So welcome to the SML21 panel. So the topic for us today is the future of semantic machine learning. Okay. So let me just give a brief, some kind of preamble, right? So semantics, right? Semantics often. People who join my team, right, ask me what is semantics, right? So there's a standard question I face almost every time. So I've been thinking, like, recently I think I have a new explanation, right? I think semantics is like God, right? You can feel it, but you can never explain clearly, right? So I think semantic machine learning in some sense is like taking God's power, right, and fusing it into ML and see what can we do with it, right? So I think that kind of gives a feel of what is semantic machine learning. I mean, this is something I came up with only yesterday. So anyway, I think the future of semantic machine learning, I think what we are looking at is how can we use the power of semantics? Yeah, again, imagine like God, it's what can you do for ML and yeah, we look into exploring different aspects of it. So to unwield this God's power, right? So we have, I think, 3 gurus here, right? We have Chris, Shonali, and Amit. So I thought I'll just say a few words. I think Chris is because I said gurus, right? So Chris is like the initiator, right? The first time, who really showed me the true power of semantics. So is in some sense the initiator, and of course Shonali, I already said a few words. Shonali is was crucial and responsible for my transformation of like initiation into the next level, right? So and Amit, of course, Amit means boundless, right? So he's like the Dronacharya, and I'm the Eklavya, right? So yeah, I think it's a great pleasure to have 3 of the great gurus of semantics, machine learning area with us, and yeah, I think the disciples.
I will always remember this Dronacharya. Unfortunately, many want to get it, but okay.
Yeah, anyway, I think I got your attention now. Let's move on to the structure. Okay. So actually, yeah, the panel structure is something like this. So this is what we thought of. So basically, it's like there are 3 segments. So okay, the first segment is going to be like general, like 3 open questions, and we'll let the the panelists share their views, and the second segment is going to be like a panel to panel. So where each panel member will pick up a question, and the other 2 panelists will go ahead and answer, right? So the third segment, of course, to the audience, right? So that is the general structure. So what I did was like, I shared this with the panelists one day before, and they all had a look at it and prepare themselves. And I guess that's not very fair, right? So I have a surprise segment. Okay, so let's finish the 3 segments, and there's going to be a surprise segment. Anyway, let's get started with the first segment. And I think, so the order, I thought like, we'll just follow the alphabetical order of the family name. So I will let to start off.
Right?
Yeah.
I'm starting. Okay. So please, Raja, please leave the questions on the screen because that's very helpful.
Yes.
Yeah. Otherwise, I'm sure to forget them. So it's quite a difficult question, the first one, because I mean we wrestle with definitions of semantics, definitions of machine learning, and now we have this hybrid, which is different ways in which they mutually benefit from each other. I mean, I think it's Frank van Hamelen is the first person I heard talk about leveraging semantically annotated data to accelerate machine learning. And I think that's pretty standard now. I think, you know, people accept that if data was semantically annotated, the ability to build learning models from different data sets, you know, could be accelerated, and you know, I guess more data is available for developing models for the things you want to do. So I guess that's clearly one, but I think that's probably, you know, we're going to go beyond that. You know, I guess it's not just the availability of data sets, it's the types of information, the semantic types. So, you know, it's the richer the knowledge, the structured data that maybe was unstructured before, you know, the better the contribution to machine learning. So, you know, I guess I'm kind of happy to sort of start that off but draw a line there, because I think it's a question that we should sort of go around maybe in cycles between the three of us. Maybe that's a good start for the next person. Is that fair?
Sure. So, Shonali, would you like to?
Sure. I guess I kind of said what I believe, but let me try and answer this. To me, what is semantic machine learning and what is not, I think, is where we only have data available to the machine. I think is not semantic machine learning. I mean, that would be a simpler, sort of simplistic maybe way of looking at it, but I would see it like that. If the machine is only learning from data, I feel that then it's not learning from explicit knowledge, right? Knowledge represented in the form of some kind of knowledge. It's all knowledge implicitly embedded in the data, right? Of course, it's knowledge in some form, but it's not, I think some of the explicit representations and context is not available in that form, right? So, I mean, that would be sort of how I would see it. I think that really this is, you know, I see that it's a very important thing that we would need to do as there is more and more demand from people who use AI and machine learning for explainability. And I think some of us, we don't think of it so much because we are naturally not in worlds where this is important. But you know, when we are in domains which are regulated and audited, and people want to use AI and machine learning, then explainability of some form is absolutely critical. In fact, it's not a very high bar. Without that kind of basic way of being able to explain how, I mean, why a decision was made, you cannot actually get this technology being used at all, because things like audit and regulatory constraints will not allow it to get there, right? So things like, you know, loan applications, for instance, credit is a highly audited area. I mean, regulated area. There are lots of regulatory constraints around that. Anything in the financial services is so regulated. Health is probably also very regulated. So these are areas where, you know, the machine just saying that, yes, this is the decision will not lead to its uptake. And I think that's something that we have to seriously look at. And I think that is where this technology of semantic machine learning will become more and more important. I feel that in the future, we are really heading to a world where it'll almost be the norm to have machine learning methods which work with both data and knowledge coming in, right? Context, data, different kinds of knowledge representations being fed. And I think that today what is happening is we are doing it in a very ad hoc, you know, I need to do it, so I do it in a certain way. Somebody may do it in one way. I think we will evolve to a point where this will become the norm, right? Algorithms which are developed will have to learn with both data and knowledge almost seamlessly. I mean, I hope that is the future anyway.
Okay, thank you. Thank you, Shonali. So Professor Amit, can we have your views, please?
So there was a paper I wrote in 2005 when we launched a journal, Semantic Web and Information System, and for a few years, 10 years, I think it was a significant journal. And in that, a paper was titled Semantics for the Semantic Web, the Implicit, the Formal, and the Powerful. So the point I'm making is that there are many ways people use this word semantics. Very early in 1989 or in 1980, 87 or 88, I define it as very simply as semantics is to associate meaning, as and use of data. Basically, it's about meaning and the use of data. Semantics is about meaning and the use of data. Um, but there are many ways people have used the word semantics. For example, they use the word semantics in the context of linguistic, and that's not the general form of semantics that we use here, or that I would imply. Nevertheless, uh, the form of semantics where we describe the meaning with the help of some model. It could be knowledge graph, it could be ontology, it could be anything where here is a text syntax and you do a reference link to a concept that is generally agreed upon, commonly understood, where there is an ontological commitment, as you may say. That uh, you know um, uh, uh, meaning that is commonly understood by first human and then machine is becoming more and more popular. And I would basically say that um, the semantic that would be more meaningful and useful in the context of semantic machine learning would be that form of semantic. That is one thing. Um, and so when you say what is and what is not, I would basically say that, well, the people continue to use semantics in many different ways, but what is going to be important, it will be the form of semantics where there is a concrete description and definition of the of any object, any word, any pixel kind of thing used that is described in common terms and commonly understood terms. So as that form of semantics is used, so knowledge will play a very important role there. Knowledge representation will play a very important role there. With regards to machine learning, then that would be the that is a semantic machine learning that I would like to spotlight on. Um, I recently attended, now it's been about 10-15 years where, in that semantic of for the semantic web, I talked about complementarity and a need for semantics, both as in implicit semantics that is possible with machine learning, which cannot explain, and the explicit or formal semantics, where you can use the model or ontology. Um, Recently, this thing has become very popular because while I was kind of part of semantic web community for a while, we were not as influential as the people in machine learning or deep learning have been, right? Those of us who did earlier more on the uh, you know uh, the discussion logic or even linked data have not had as much impact as the people coming from the statistical AIs had. um, so I and some others probably talked about this integration of semantics and machine learning and knowledge in machine learning. But recently, these guys have been really talking about it. The first use was that, I mean, I can recall now, is a 2012 paper by Pedro Dominguez, where he did that kind of survey write-up on machine learning. And the title of his section number 4 in that paper was "Data Alone is Not Enough." Right. And this was a kind of, for me, the first time I started hearing from these people coming from the community. There may be other users. This is something that I remember very vividly. After that, I heard um, Oren Etzioni and many other people, including now one of the 3 Turing Award winner, the one from Canada. They have started talk about very important role of knowledge. And there was another panel at NeurIPS in one workshop, and there again they talked about essentially important role that knowledge is going to be play with deep learning. So what is happening is that this you know while some of us had looked at, and we saw the power of deep learning, and we wanted to integrate knowledge with deep learning. So we're working on that. But this very larger group and more powerful group has also gotten the religion. So now you can be sure that this has already gotten massive, I think, shot in arm. And even the hardcore, machine learning conference of NeurIPS and ICML and others, you start seeing the papers on use of knowledge. So now whether they will they may not use the word semantic machine learning because they are not accustomed to use the word semantics, but they are going to use certainly knowledge because it's a generic term, right? So I'm going to see that I'm pretty convinced that what we are talking about here, generally what we discuss, that with semantic replaced by knowledge enhanced machine learning, knowledge enabled machine learning, I started using the word knowledge infused machine learning. This is going to be blockbuster. Even when last I attended 2020 AAAI, one of the major most important theme that came from that was neuro symbolic computing. Well, within that context, I think people are increasingly resorting to the use of knowledge, as I try to make case in my talk. So the other thing that is going for it, which I should not repeat anymore. I talked about interpretation and explanation, and Shonali also talked about it in a very persuasive manner, coming from the the need to sell these solutions to industry. It would be become so. So what's happening is that there are a number of approaches for explanation in deep learning, and most of them, in my view, are not going to be as successful as the ones that do involve knowledge, explicit knowledge. And hence, I think you're going to see, but at the same time, explanation is massively important. So, explanation is necessary for trust, and so for any of the many things. So, because of that, also what we call, here semantic web in this workshop is going to be very, will grow very fast. In fact, exponentially, whether or not they use semantic word or not. So, well, anyway, that's my take on these questions.
Thank you very much. So now let's move on to the second question. I think the second question is like, so in this workshop, so from the 4 talks we have seen, like, the semantics could be, could work with AI, ML in so many different ways. So, I mean, of course, there are a lot of other papers. We've read a lot in the last, few years. So I think the question is like, in your view, right? So what are the, like, maybe the top 3 ways, right? Something like the top 3 ways semantics could work with AM, XML to maximize impact. I mean, in whatever way you interpret it as, industry impact, societal impact, or even, AI for good, that kind of impact in the next 3 to 5 years, right? I think that is the topic, and probably you could explain it, like why you would rank them as top 3, and what are some potential roadblocks to make this happen? Right.
So you want me to start again?
Please.
Okay, great. So, I've actually, I'm working on a paper at the moment about the adoption of agri-semantics, so semantics in agriculture. And we started this through a series of informal discussions with people in the agriculture space, right? People in companies, in government, in research institutes, and to really get an understanding of whether they'd even heard of semantics or how they would even leverage it. So, whether they're leveraging it for machine learning or for some other purpose, we were interested as to why. And I've got a little table here from the paper. And so we asked a series of questions. And I mean, we were saying, are you using a a common vocabulary for any of your activities, right? Are you using ontologies to annotate existing data, right? Do you create formal ontologies with axioms, right? Do you do formal reasoning with ontologies? Do you integrate text mining with ontologies? Do you query knowledge graphs? You know, are you inferring new knowledge from hierarchical knowledge representations? Are you annotating web services, for example? So all of these things are ways in which people are leveraging semantics to some degree, right? You could imagine maybe if somebody was reasoning over a formal ontology and deriving some new facts that were not explicit, but they were implicit, and you can do that with subsumption hierarchies, and that knowledge was, you know, it's condensed inside a formal ontology in a very rich form. But if that is then learned from the reasoning of the ontology, and then that's used to train a machine learning model, you know, then you actually got, you know, the knowledge representation of the ontology is just a very rich source of implicit knowledge, right? Condensed, I mean, like I said, through, you know, hierarchical representations. So, you know, in the same way that, you know, somebody who's written code would extract maybe the names of car manufacturers from a document, right? And you give them another one which hasn't been seen before, you know, a new car manufacturer. And then you maybe go into the product and you realize that it's a three-wheeled vehicle. And well, is that actually still a car? So you can go and look up and figure out whether, you know, a three-wheeled vehicle is actually a car. And then once you've checked that, which is what you do with the formal ontologies, you do a lot of checking. You can take that knowledge and say, yes, go and extract that information also from in the NLP task. Or you could say, yes, include that type of information in the machine learning model, right? So the knowledge representations are basically a resource, clearly a resource, a very condensed, interconnected knowledge. And I think, you know, I think over time, people will start to leverage ontologies not just as simple data schemes or, you know, terms for annotation, but they will start to leverage the rich knowledge inside the ontologies, which is kind of portable, and using that in the machine learning models to make them be able to learn faster from a wider range of implicit knowledge. So I'm going to stop there, but I think that was plenty for the time being, but we can come back to it.
So a related question is like, so when you mentioned formal ontology, could there be like roadblocks, like, you know, it gets tedious to, you know, I mean, code it, or it doesn't get very scalable on.
I think
like what could be like some roadblocks?
So the challenge we have fundamentally is that there is lightweight semantics and there is much richer semantics. And so we are talking about something which could be rich or weak semantics, right? And so each of those have slightly different roadblocks. I think the roadblocks for people to leverage formal ontologies and into machine learning is there's a learning curve, right? I mean, does a machine learning expert know how to query with Sparkle? Yes, they can learn, right? Do they know how to use a reasoner to infer new knowledge from an existing ontology and use that in their machine learning model? Maybe not, right? So there's a learning curve. That's one roadblock. So that these communities have to kind of work together, but that's going to be a challenge in itself. But I see those I think that's an interesting direction because, you know, so many people have invested a lot of time in building rich knowledge representations, and they sit there on the shelf somewhere, right, used by very few other people, right? And the whole point was that they were meant to be portable knowledge resources. But they're almost too complex for people to reuse. So the reuse of rich knowledge representations is actually a problem, and that's either because of lack of education or we don't have tools to facilitate reuse. So those are some roadblocks. Because if you're a business analyst or somebody working in a business context, you don't have time to go and learn to be a semantics expert, right? You need easier tools, right? And that was always we have we have Wikidata as a next generation of DBpedia. It's a next generation technology and it's much easier to use. We basically just need to rebuild the tools so that they're accessible to a broader range of people.
Yep, especially in this generation, we're all gasping for time, right? So, yeah, understand. Fine, thanks, Chris. And so can we move to Shonali? Okay.
Yeah, thank you. Thanks, Raja. Thanks, Chris. Yeah, so we've talked a lot about formal explicit knowledge representations and ontologies and other rich knowledge structures and knowledge bases that exist. Actually, there is another kind of knowledge, and Hemant kind of alluded to it when he asked me a question about humans and so on. There is actually informal knowledge as well. And that informal knowledge is also a very powerful thing, that today the way that informal knowledge gets into the machine learning model is really through conversations, right? There's conversations between the people who are building the model and the people who know this domain. And through those conversations, certain knowledge, whatever they have, is then translated into basically structured features that go into the machine learning process. And these features are often the most important features for a machine to be able to make certain decisions, right? So very simply, just understanding that, and I will go back to the example that now that dominates my mind, which is health insurance. So let's say the intuitive thing is that, as somebody gets older, they are going to fall, they're going to fall ill more often, health will deteriorate. That's just the human condition. Now, apparently, there is one class of persons for whom this intuition is not really particularly applicable in health insurance. And these are what are called the ultra high net worth individuals, because they're extremely wealthy. They have all sorts of healthcare facilities, and they're able to spend that much money. So apparently, when somebody who's older but is a high net worth individual applies for, puts in a policy application, that is treated differently. Let's say you and I applying, if for health insurance, and our age will be a determinant factor, right? Now, this kind of almost anecdotal, it's just counter to the data that you might see, because there's very small data that will represent all this. This kind of information also somehow needs to come into the process, right? I'm really going into the future now. But how does one then capture this kind of information, which is, also important knowledge, and bring it into the process in some structured, less conversational, less human intervention based approach? I think this is something that we should think about, because there is some knowledge, obviously lots of knowledge, which can be formally categorized. But there is a class of knowledge which is informal, that comes with experience, that is almost anecdotal, but can be very powerful. And when we want AI systems to really behave like human beings in the way they're making decisions, then these are the kinds of also additional information that needs to be brought in. Now, how to represent this and how can machines actually leverage this information? I think that's an open question for people to think about. But then I guess that's the purpose of the panel, is not to answer questions, to create more questions for everybody to go and do something about it, right? That's one. The other point that I wanted to make is, you mentioned all the large bodies of knowledge bases that have been created, not really leveraged. We did recently start looking at using, some medical ontologies that are publicly available, and they're available through API calls and so on. And this comes down to another open problem in the insurance domain, which is that today, when you read all these invoices, you see Panadol, erythromycin, you see something, whatever. they categorize this into some high level blocks like medication, doctor consultations, whatever, right? So this kind of thing, if we want to automate it, right? So I think that's where ontologies actually have a very almost immediate use that we could leverage on. So we actually ended up using some open ontologies to do this categorization for us, at least for a large number of things, right? But here we are not only relying on ontologies. Ontologies might be able to tell me that Panadol is a kind of medicine, but then there are some things which are just human experience, right? And there's some things which are just, the way that is done in an organization. So there are multiple facets that need to be considered. Not everything can be captured or represented in this ontology. Some of it is really just the expert knowing that this process is if it's a well-known surgery, then it's good, that it is a surgery, but there might be all sorts of other procedures, and there might not be a very good representation of all the procedures that are being done. So anyhow, this is again this view that I take, that today, if we want to solve problems, we have to look at multiple combinations of technologies coming together. And I think that's really the most powerful way of really building true solutions that work at scale.
Okay, thank you, Shonali. So Professor Amit.
Oh, I thought I kind of answered all the three questions in my first go. What I would just say is that in the first 20 years of semantic web, it's clear that heavy duty representation of semantics doesn't work too well. So if you saw on one slide, I showed you a lot of knowledge graphs, and these are the ones that are actually being used, and they are there. And there are 600 ontologies on bio portal, and I didn't talk too much about them. Thankfully, I was pretty clear in my mind that because I did that company, right? I founded a semantic web company in 1999. And I realized that description logic or anything first order logic and all that is just not going to work. Multiple reasons. There are reasons that everybody's talked about, but one other reason I learned was that look at a typical graduate coming off, and look at a typical software engineer with 2-year work experience. These are the kind of people I would hire at junior positions. Do they know and do they have affinity for using logic? And what is the cost of building that and maintaining that? Because it is appealing to use those formal representation if you want to worry about this completeness and that kind of thing, consistency of knowledge and completeness, and you want to argue about those things. Who cares for that? The knowledge is constantly moving. If I'm using ontology to capture the knowledge, I'm interested in the descriptional, the instance level information, not the constraints and other things that is modeled at the schema level. I'm looking at instances that there is this stock, it has this stock symbol, blah blah blah. And for that, the little less formal and little lighter way, where you basically have entities and relationships, work perfectly well. And essentially they map very well to the graph model. And everybody has learned graph data structures and knows how to program with graphs. And people know the complexity of dealing with the graphs. So there are some other issues even with the graphs. But essentially, the data model I had myself use RDF and had papers in RDF before the time it became standard in 98. But I chose to use property graph level of representation that was adequate, efficient enough, scaled, all that kind of stuff. So what the semantics that is going to be used in AI/ML is going to be again that kind of semantics at the middle, somewhere in the middle, not the heavy duty semantics requiring OWL, and not the extremely weak semantics involving bag of words and just pure only the taxonomy. Taxonomy is fine, may be used, but somewhere in the middle, would be the sweet spot. And that is the kind of semantics that we're going to continue to see a lot. In terms of the roadblock, I'm very, I think, optimistic that because the AI people are looking at knowledge graph and kind of not the formal semantics, not the logic, but the practical ones. And you saw, I mentioned to you in Amazon that everybody's using knowledge graph, and Google and Facebook and everybody, LinkedIn, everybody has knowledge graph. If they don't have it, they by the way license from other companies. So there's Samsung decided the cost of developing their knowledge graph is too high, so they're licensing it. As far as I know, at least last time I knew that is what was happening. So there is there's open source data, and Wikipedia, Wikipedia, Wikidata, all that is there. But there is also a commercial systems where people provide you usable knowledge products, and so that with that kind of both ways progressing, I think users of knowledge that will support semantic solutions have what they need. So and given that now these machine learning people, deep learning people are heavily adopting knowledge, enough of the segment. So of the 3 Turing Award winner, only Hinton says, no, I'm not going to use it. The other 2 are, very much into this, especially, I would say, the one from Montreal. So and Lukun also is kind of pretty receptive to use of knowledge actually. So with that high level support from all the best in that field, of course Etzioni I mentioned and many other people, I think that this is going to be kind of sucked in. They're going to co-opt. In fact, what is going to happen is that I see that them owning up to the semantics and knowledge, and then the old semantic web people or semantic people are going to be with them in swimming, but not necessarily remain apart from that. So anyway, that's the thought on this thing. So I don't see a huge roadblock because as I said, I showed you the examples of shallow infusion, semi-deep infusion, deep infusion. We figured out pretty much the first 2. Deep infusion, we are working on it. The reason that is challenging is that it requires you to have stratified knowledge, knowledge and abstraction. So in addition to this personalization context, which is very important in knowledge, and semantics play a very important role, the abstraction is something that humans have. And we are able to talk about things at level where you can say, I understand him, but without having 100% agreement, or without, my words go out to you, and you may say, yeah, I understand what he's saying, but that doesn't mean that we have to worry about 100% agreement with what, each of us are saying. I think you got enough of the sense, and that's good enough for you. And that's good enough for me. So I think that we will do fairly well with that level of, but to support that by the abstraction is going to be hard. And that goes to a deeper issue, but I think we're going to do fine. It's just a process, that is time it will take for us to get there.
Okay, yeah, thank you. So now we come to the third question. So which is really looking into the crystal ball, I guess. So I mean, these days we have like every year, GPT-3, GPT-4, they're making leaps and bounds of progress. So I think semantic ML after 5 years, like, what are your some predictions or trends? Right? I mean, that is the context of this question.
Yeah.
Chris, yeah.
Yeah. So, it's always fun to say things when you know that they may or may not come true. It gives you a bit of freedom. I think that, semantics is one of those things when you, in a process, you need it maybe for 10% of all the activities. And then you don't need it again for another 6 months. And then you pick it up again because, your system you were building operates fine, but all of a sudden it needs some new knowledge, or the knowledge that you had was, you know, not rich enough, or, you know, something needs to be more expressive. So semantics goes in cycles, is kind of where I'm coming from. And I think that certainly with the growth of knowledge graphs and the kind of lightweight semantics, you know, there will be people that will still reach back to the more formal semantics. So I think, you know, as Amit said, we still need the taxonomies. We still need these subsumption hierarchies. We like the domain and range, but I think people will continue or start to add a more axioms into their knowledge representations. And we will leverage those axioms, really, because it's a shorthand way of capturing knowledge. I just give you a point in case. We have a project working on cybersecurity, sort of phishing emails. And we want to be able to predict what kind of strategies people use when they write a phishing email. Or can we classify phishing emails according to a persuasion strategy, right? You know, this phishing email is trying to get me to do this. This other phishing strategy is trying to get me, you know, to feel guilty about something, or, you know, another one is, you know, the greed. So this model, these different persuasion strategies are difficult to model. And when we connect that to the data, that, you know, the phishing emails themselves, we want to do some checking. We want to check whether this email has or was driven, you know, this was a certain type of phish attempt to get me to do something. Machine learning itself, you just feed the system a whole bunch of phishing emails. Somebody needs to train that, sort them. You know, or if you're using unsupervised, you still need to annotate clusters. So I think there will always be a role for the formal semantic. It's just, it will not be the main activity. It will just be an essential activity that's still there, and somebody has to do it. But you're not going to hire 200 ontologists. You're going to hire one, right? So we will continue to need semantics. We'll need it to help us sort of represent knowledge that we will then leverage inside other activities, because machine learning itself will not, you know, without the good quality data, right? You won't necessarily, you know, have good high predictive value, because fundamentally you need explainability, but also you need obviously high predictive value, and the data needs to be good quality, clean data that's precise, and you need that, I guess, in real time. So semantics will facilitate the quality of the data that's used for machine learning. And I mean, Barry Smith, you may have heard of him. Barry always said that in every library there will be an ontologist. And, you know, he said, I'm not sure when it's going to happen, but there will be an ontologist somewhere in a library, somebody who's categorizing knowledge, right? Now, okay, that won't necessarily be in every library, but, you know, libraries will rely on people that are ontologists. I think that's the key. Anyway, so that's plenty again from me. I'm not sure what time frames, but and maybe I'm thinking like 20 years, but anyway, there you go.
Okay, thank you, Chris. Shonali, you want to try?
Sure, I don't have much more to add, but I will just sort of, I think, you know, Amit made a very good point that I'm probably not seeing because I'm not too involved in the academic conferences at this point of time, that, you know, the machine learning community is also talking a lot about knowledge being an important ingredient in the machine learning process. Coming from where I am also, I see that it's a very critical thing. So I think that in the future, be it 5 years or whatever it may be, we are going to see a class of machine learning algorithms that can learn from explicit representations of knowledge like knowledge graphs, etc., coupled with data. And I think that is very important, that we do need to have data as it is today because that's available in plenty. But coupling this with any kinds of explicit representations of knowledge would, I think, becomes would be the norm, if you will. And I think that's going to happen. I see that happening. Yeah. That's
Okay.
probably, yeah, thanks.
Thank you. So Amit, any last words or like?
I'll pass. I think I've said more than.
Okay, that's good. That's nice. I think we're running short of time. So I think maybe let's move on to the second segment where I think, yeah, as I said, each panel member pick a question and post it to the other two, and the other two, yeah, answer those questions. So this time, maybe I'll let Shonali to start off. Okay.
Maybe if anybody wants from the remainder of the people who are listening to us, maybe they want to ask.
Yeah, I think that would also be good.
I think it's already 8:05.
Yeah. I mean, if you have no more questions, fine. Yeah, I think we can go to the.
I just sorry, just one question I have. Do you still use the word RMA?
RNA.
RMA.
No, I don't even know what is. Clearly, I'm not using it.
It stands for request for manual assist.
Okay.
So you talked about, right, when the system throws error and you have to do the things manually.
Yes.
So this is a word that is from old telecommunications.
Okay. Clearly, I'm not that old, so I'll have to go look it up, Amit. But thank you for the point.
I mean, Shonali, would you want to ask any question, or shall we move to?
I think I'm happy to get audience questions. I'm very happy to see, just a point more than a question. Very, very happy to see Amit online. Obviously, I'm very happy to meet Chris as well. And, it's been so many years since I actually saw and heard Amit. So it's really very nice. Thanks, Raja, for the creating.
Mutual admiration.
The audience, I can't see the audience poll. Are there any questions? Hello, I think that's.
Audience, yeah. So if audience has any question, that would be a good time to ask.
Anything. Yes, anyone?
Looks like everybody wants to finish up soon. So I'll have just one question about the, this evolution of knowledge, that as our cultures are changing, as our society is changing, and so would be this knowledge basis, right? And the cost of the models that are built with this knowledge basis, which are outdated, which are having outdated knowledge, but you have incorporated them as a part of the models, right? It will have very severe implications. And I think you brought a good point regarding the reliability for the models, and where the situation is highly regulated and audited, Shonali, right? In those kind of industry, it becomes even more important. And here we are just, talking a trend that we will see increasingly the use of knowledge resources, right? So how do we kind of come up with forms of metrics, like measures that would allow us to better capture this notion of like this outdated knowledge well in combination with this use of these models in practice, where we start to see that it becomes like almost reactive, right? That when actually missile has gone, then you realize that, oh gosh, our model was bad, right? And then we go back and debug. And also, what are your thoughts on like thinking about, as given you have lots of experience of MLOps there, having this understanding, can we debug in process and not after the process? So.
Right. Okay. I just have a couple of points. It's a very, very good point. So I think outdated knowledge and even just outdated data is something that we have to cater for. And I think, it's not something that we can wait for a long time to deal with if we want to make this kind of thing work. We really have to cater for this kind of thing in the systems that we build. Very simply, for instance, let's say a product that has certain benefits associated with it. And let's say at a certain point, a business decision is made that, okay, from now on, this product will no longer have dental benefits associated with it, right? So then if the machine has already learned that for this product, you can pay dental benefits and now you have changed it, then you actually need to work that into your system in the way that this is running. And this is very much part of that model maintenance and ML ops aspect of things that we didn't touch on, or at least I didn't have time to touch on. But this is really a very critical way of providing feedback to sort of say that certain constraints in the environment have changed, and you then want your machine learning systems to cope with that. Now, can the model automatically do it? Today, I don't know. What we do is we deal with it at a systemic level, right? So what you then need to do is you have to have processes or basically code in place to go and change your features, your data, your labeling logic, and so on, so that this model can now actually learn that there has been a change in the environment that it has to cope with. So you have to think about these things. We do something very simple, which is really basically get the constraints and use that to relabel the data and then retrain the model. So this is a very simplistic approach, but it works for the moment. But more formal, generalized methodologies to deal with this kind of thing is, I think, it would be important, absolutely.
Okay.
The concept drift and the change of is an example where the real world changes, and something you're trained doesn't work. A concrete example is we trained our sentiment analysis algorithm during 2016 election during primaries. So there are all these 10 Republican contenders, and the algorithm started performing very poorly once it got into the general election phase with Trump and Clinton only. Um, uh, so it affects things in the learning algorithm, so as well as it affects anything which is knowledge dependent. And practical point I will make is, given that I also done my fair bit of commercial activity, that unfortunately the builder of systems don't give enough thought to it, because it is pretty costly, and they want to get the product out, and they will pay attention only after the cost of not attending to the change in knowledge, change in the real world, and how we are modeling it. It becomes clear. You take or and just I'll throw two very interesting point. The famous GPT-3 model was trained for the data until October 2019. What the hell is it going to do with 2020 election? And think about any AI system that is about, let's say, this big thing going on with the events on January 6th, where insurgency happened, and event on January 20, where Biden was finally actually declared. Uh, uh, Now what happens? The whole worldview of the people who were into QAnon, how do they deal with it? And so the knowledge changes, the knowledge about the group changes, the whole way to account for their participant changes. And these are very, very interesting cases for us to do more research in. But the standard vanilla machine learning pipelines don't cater to that yet at all. And I think some spectacular failures or big clarity on the cost of not doing that will hopefully lead us to do more about it.
Okay, but thank you. Maybe we'll, in the interest of time, I guess we're going to stop sharing. Let's
Can I ask a quick question?
Yeah, sure, go ahead.
So I have a quick question from Dr. Amit. So my question is related to semantic knowledge graph. So one of the challenges there is just incompleteness and missing knowledge. So what do you think going to be good directions to handle this problem, like in the future? So what is your idea?
A while ago, I wrote a paper on semantics for search, integration, and analysis. And very fundamental thing I observed there was that when you use these, techniques, it could be search, can use machine learning. If the end product is going to be used by human, then you can take a lot more liberty. Your knowledge does not have to complete whether you get the result on the first, listed first or fifth, you will still survive. The human brain is working on analyzing the results, and before it is actually used for whatever purpose the person was doing search. There needs to be more alignment if you are trying to do integration, and there has to be even more alignment of the knowledge if you are going to use it for analysis. So things have to line up, and one reasoning is from here to here to here to here. That also has to be flow and match up, right? There's no human, machine is trying to do that, and machine is dumb. Most advanced AI system is very dumb, right? So it's learned pattern from large amount of data, but what else has it learned, right? I just gave you example of QAnon. I would know on the day QAnon, this happened, that the QAnon worldview has changed, and I'll factor in as a human. Machine is not going to do that. It's going to take a lot of work to change the knowledge and worldview and world model. So it depends on the application for which you're going to do this. For some, you can take a lot of liberty of incomplete and inconsistent knowledge, and for others you can't take the liberty, or be prepared to deal with this RMAs, manual handling, and have these parameters like the one that Shonali put up, saying that I don't have confidence. In AI thing, in the research things, there is also this thing about confidence. And so the people, and there is decent research there. So you say, I predict this, but with this confidence, and then now human makes a call, whether I have to do this or not, or what additional work I need to do. So that is basically short answer to your question.
Thank you so much. Thank you.